Right, okay, so in the previous video we looked at determining the power developed by this car as it moved up the hill. Obviously some of the key pieces of information to work out that is gone now. Do look at the previous video for that explanation. Right, so we've got the car moving up the hill at 12 metres per second. Now, we're going to talk about the efficiency of this vehicle. Now, we're told, or I'm about to tell you, that the efficiency of this vehicle is 40% efficient. Now, 40% means that 40% of the energy I put in gets used usefully. Okay, 40% of the energy I put in gets used usefully. Now, there is an equation for efficiency, and that is the useful output divided by the input times by 100 will give you your percentage efficiency. So that is a standard percentage calculation, as I've shown you before in a previous video, so you just need to reuse that here. Useful output divided by the input times by 100, and that tells you essentially what your efficiency is. So in this case I've told you that the efficiency of this car is 40%. And I'm about to say that the car travels for 20 seconds. Okay? How much energy must be used by the car in order to allow it to travel up the hill at constant speed for 20 seconds? If you want to pause the video and have a go at this and see if you got the answer right, great, but we'll work through it slowly but surely here. So first of all, we're looking at using this equation. Now we're going to want to use this equation because we know what the percentage efficiency is, we know what the useful output is, but we don't know what the input energy is. Now, you might be thinking, actually, Ben, do we know what the useful output is? Well, yes, we do, because in the previous question, we worked out a power. Again, you might be saying, but that's a power, not an energy. Yes, but power is energy per second. If power is the amount of energy or work done per second, joules per second, then we can use this idea to suggest that there is 41 kilojoules used every second. Okay, because that's exactly the same thing as that. So if it uses 41 kilojoules every second, and that is our useful energy output every second, we can use that to work out the input every second. So it travels 20 seconds. I want to work out the total energy input for 20 seconds. Right, okay, so how do we work this out? Well, we need to use this calculation first of all. I'll just explain briefly what we're going to do, but we'll actually do it now. So we know that the percentage efficiency is 40%. So we need to divide that percentage to get a decimal by 100, so that takes us to 0.4. So we're going to say that useful over the input is equal to 0.4. Remember, we've already identified that the useful energy is 41 kilojoules every second. 41. Therefore, how do we rearrange this? Well, I'll do a quick rearrangement to allow us to work this out. So it should be 41 divided by 0.4, and that will equal our input energy. Again, if you didn't understand that algebra, do go back and look at the Physics Algebra Tricks video. It will help you understand algebra in more detail. So, once we work that out, we will have an input energy. So 41 divided by 0.4, it's 102.5. Doing red still. So remember, we're still in kilojoules here, and it's absolutely fine to be working in kilojoules until we get to the final answer, which we'll probably still leave in kilojoules, won't be a problem. So what we're doing then is we're saying that the input every second is 102.5 kilojoules. So that means over 20 seconds, we times this number by 20, so 102.5 times by 20 gives us 2050 kilojoules. And that is our total energy input, okay? It might be more appropriate now to just round this up to an appropriate number of significant figures, so we'll go for 2 megajoules, about 2 megajoules. So quite a sizable amount of energy for 20 seconds there. Apologies, 2.1 megajoule would be more appropriate. Okay, so that's how we utilize our efficiency equation. We've used it in terms of the previous video's power developed question to allow us to work out total energy input over an amount of time. One of the key things to watch out for here is the wording of questions. So if you ever see the wording energy per second, or if you're looking for something that happens every second, remember what essentially you're doing is just putting 1 as the time in any equation. So it's every second, then that's 1 second. And essentially that's what we've done here to allow us to do this. We're saying, okay, well, every second I get this much energy because that's the power. Okay. Right, so that completes efficiency, and have a go at some of the questions in your textbook. If you have any problems, do write them down on your notes and we'll deal with them in class.